Hey there, you're 8. In this video here, I'm going to go through the notes for exercise 9E, and this is about finding the x and y intercepts. And what I'm going to do is I'm going to use a Desmos from Google to show you the logic of what the x and y intercept is and how you can use it. Okay, so here. Remember, how many points do we actually need to sketch a straight line? So logically, how many points do you need to draw a straight line? Well, really, you only need 2. 1 and 2. As long as you got 2 points, you connect them, you make a straight line. Okay, so minimum number of points you need is 2. Now, for example, to sketch the equation y equals 3x minus 6, what you did in the previous exercise was that you had to fill in these table, or this table here. And usually in the textbook, they give you the numbers up here for you for x. Technically, you could have made up those numbers. You could have said it's 0, 1, 2, and 3. Because really all you're doing is you're coming up with a bunch of coordinates. What you're saying is, what if x was 0? What if x was 1? What if x was 2? And what if x was 3? That's what you're really saying. What you don't know at the moment is you don't know what y is equal to for every one of them. So you don't know what the y coordinate is. But that's why you've got a rule. The rule says, well, I'll tell you what y is. Y will equal to whatever x is, which at the moment we made up as 0. X is 0, 1, 2, or 3. And you're saying that whatever x is, you're going to triple it. And then you minus 6. Right? So in this case, if I were to answer the question, well, to find the y value for each particular coordinate, if x was 0, so if x was 0, well, according to the rule, y will equal to 3 times 0, and then you minus 6. So 0 minus 6 is negative 6. Again, you can use a calculator if you're not confident with negative numbers. So what does that mean once you've worked out using this rule? Well, you've just figured out it's 0, negative 6. Okay, so that's 1 point. And then you go with another one. Now, as I'm going through this, you might be saying, where did 0, 1, 2, 3 come from? I made it up. You could have picked any number you want. I just like smaller numbers because it's less multiplications to do, right? So in this case, let's say x was equal to 1. So then what would the y be using this rule? So again, y is equal to 3 times 1 minus 6. So let's do it. 3 take away 6, which is negative 3. Okay, so again, if you're not confident with it, use a calculator. So then, as you can see, I'm filling this out, and you'll probably start to see a pattern for the y's. The y was negative 6, then it became negative 3. So hopefully you see a pattern here. So if I substitute again, if x was 2, according to the rule, it's 3 times 2 minus 6. And then that becomes 6 take away 6. 3 times 2 is 6. And 6 take away 6 is 0. Are you starting to see a pattern? So it went from negative 6 to negative 3 to now 0. So what do you think the next one would be, even without the calculations? Hopefully you realize that it's just adding 3 every time. So this is now 3. And you can test that by saying, well, if x equals 3, according to the rule, y equals 3 times 3, which is 9. And then you minus 6. 9 minus 6 is 3. So here we can say then it's 3, 3. So these are our coordinates, and I just picked 4 random coordinates there. But you can see in the previous exercise, you would have had 5 or 6 coordinates, and then what you would have done next is you would have started plotting these coordinates. You would have said, well, where is 0, negative 6? So 0, when x is 0 and y is negative 6, well, it's down here. This is where 0, negative 6 is. And then the next point was 1, negative 3. So where is 1? Well, 1's over here. Okay, so 1's over there. And then negative 3 is 1, 2, 3. So negative 3 is down here. So that's at 1, negative 3. And then you say, well, where's 2, 0? Well, x equals 2 is here, and y 0 is exactly on the x-axis. So it's 2, 0. And then lastly, 3, 3. Well, this is 3 over here. And so 3, 1, 2, 3. That brings me to this point here, which is 3, 3. And what you should see is that the points end up giving you a picture of a straight line. So the pattern is that it ends up looking like a straight line. But the 2 key things that you're learning today is notice the pattern of the x and y-intercept. Now remember, this horizontal line is called the x-axis, whilst this vertical line is called the y-axis, right? So that's your x and y-axis. And so we call this the y-intercept, okay? Because it intercepts where the y is, or where the y-axis. And then we call this the x-intercept. Now, there's something special about the x-intercept and the y-intercept, because remember we said you only need 2 points to sketch. So why did we plot 4 points just to sketch a straight line? All we needed was actually 2. We only needed 2, and one of the 2 great points to pick is the x-intercept and y-intercept because they have a beautiful property. That's what I'm going to show you. Okay, so I'm going to write down here, x-intercept was 2, 0 from what we saw. And then the y-intercept was 0, -6. Now I'm going to use Desmos to illustrate a point, and hopefully you realize what the pattern is, okay? So why is the x-intercept and y-intercept so special? Here we go. I'm going to grab out, let's get Desmos. You can do this too. Go to Google, type in Desmos, and then the first link where it says graphing calculator, if you click on it, you'll get to Desmos, and it looks like this. Now let's type in our equation. Not our equation, actually. It was... what was it again? Oh, yeah, I wanted to show you the pattern of the x-intercept and y-intercept. So we had two points, so bracket, -2, comma, was it comma? No, 2, 0, wasn't it? 2, 0. I think that was our, yeah, that's our x-intercept. Now, I want you to have a look at this. This is on the x-axis. That point is on the x-axis, right? So it's at 2, 0. Let's say I pick another point, okay? Let's say I picked at the 1, I want it to be here. Well, you would have wrote down the point at 1, it would be 1, 0. Can you see that? So this is an x-intercept as well because it's touching the x-axis, right? So then let's pick another point. I'll pick over here. If I want it at -4, I would have had it at -4, 0. And so if I label that again, it's still on the x-axis. But are you starting to see a pattern? You see, if I zoom out and I said, let's pick another random number. Let's say I want it over here at -15. Well, then I would write -15 and again, 0. So what's the pattern? What's the pattern? Every time I want it on the x-axis, right? What do I notice? What's the pattern about all these 4 coordinates here? So if I took a picture, what's the pattern of all 4 coordinates? So hopefully you're starting to see, or at least you would have noticed, and you might have been thinking about it, but I'm just going to move it down here. Let's analyze it. Let's have a think. I picked out 4 random coordinates, and those 4 coordinates, what do they have? X-intercept was -15, 0. I had -4, 0. And I also had 1, 0. And I also had 2, 0. And what's the pattern about them all? What do they all definitely have? And hopefully you picked up that as long as y is equal to 0, the y coordinate, if it's equal to 0, you will have an x-intercept, meaning a coordinate on the x-axis. This is the x-axis. Okay, so let's test that theory. So I can pick any number. I like number 3, so I'm going to do 3, 3, 3, and then comma. As long as the y coordinate is 0, it will always be on the x-axis. Let's see if that's true. I'm going to zoom out. Let's see, where's 333? 333 should be over this side, actually. There you go. 333, and you can see it sits exactly on the x-axis right there. Okay, so it actually doesn't matter what the x number is. It only matters that the y coordinate is 0, and it will sit on the x-axis. So every time you want to find the x-intercept, you know the one fact, y must equal to 0. Okay, write that down. Write that down. That's a very key concept that a lot of students just memorize, but they don't understand that every time you want to find an x-intercept, the pattern is the y coordinate must equal 0. That's the logic. Yeah? Next one. Same thing with the y-intercept. If you look at the pattern for the y-intercept, let's see the patterns here. I'm going to delete all of these ones. Okay, let's go delete, 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 and we'll go back home. Let's have a look. Let's pick coordinates on the y-axis. The y-axis is the vertical line, right? So let's say I want to pick it at 4. If I want a coordinate there, notice it's going to be 0, 4. That gives me the y-axis intercept at 4. If I wanted a coordinate at, say, I don't know, -2, So I do the same thing and say, all right, well, 0, -2 gives me the point on the y-axis, and that's now at 0, -2. Can you see that? So hopefully you're starting to see a pattern as well. Are you starting to sort of get the picture here? So if I wanted 20, for example, if I wanted a y-axis intercept at 20, then all I have to do is I just say 0, and then I say 20. And then I put a label. Can you see? It's at 0, 20. So out of those 3 coordinates, let's go back here again, and let's do the same thing. So 0, 20, 0, 4, and 0, -2 gave me, so 0, 4, so that's 0, 4, 0, -2. What you noticed again, what is the pattern? Every time you want a coordinate on the y-axis, what had to occur? What was the pattern? And hopefully, again, you realized that the x-coordinate had to be 0. So let's test that theory again. So as long as I make x equal to 0, so the x-coordinate is 0, you can pick any y value, whatever number you want. So let's say you wanted 80. Then if I put in 80, 0, 80, and then I put a label, you can see where it's at. It's literally on the y-axis, and that's not by accident. It's just facts that to be on the y-axis, x has to be 0. And so here we say that for the y-intercept, we know that x must equal 0. It's a very simple idea, but most students tend to forget or not understand that idea. Okay, so here we go. Let's do some examples now. So how is this relevant to us? So instead of doing this before, let's tie it all together, yeah? Instead of plotting 4 coordinates here, you had 1, 2, 3, 4. And to do that, you had to calculate 4 different equations to get 4 different coordinates, right? But remember, we knew you only needed 2 to sketch a straight line. So if you only needed 2, why are we doing so much work for it? So let's start again. Let's say I wanted you to sketch what this one looks like, okay? Y equals 3x minus 6, okay? Then, and it looks like this. I'm just gonna delete this. Going back to Desmos, I'm gonna type in y equals 3x minus 6. That's what the equation looks like, okay? Now, to find the y-intercept, okay? Remember, y-intercept means that you're gonna cross the y-axis. So what was the pattern every time you cross the y-axis again? We know that x is always 0. So some of you might have forgotten that idea already, and that's what I mean. There's just something about it that students don't truly understand it yet. We just know that the x-coordinate always has to be 0. So what I want you to write here is to find the y-intercept, we know that the x-coordinate must equal 0. Okay? So if we know the x-coordinate has to be 0, we'll then substitute x equals 0 into your equation, because that's what you said. We've got a rule. We said y equals 3x minus 6. And what we're saying is, if we know the coordinate is going to be 0, all you have to figure out now is what is y. So to work out y, you've got a rule for it. So here, the rule says 3 times x, which we know is going to be 0, or we want it to be 0, and then you minus 6. 3 times 0 is 0. 0 minus 6 is -6. So y must equal to -6. And what that means is your y-intercept is at 0, -6. Get me? This is your y-intercept. So let's see if that's true. If I type in now, in the equation, I type in 0, -6. Can you see on that black line, it actually crosses the y-axis at 0, -6. See that line intercepts right at the y-axis at 0, -6. And we didn't have to guess it. We calculated it. So there we go. We've got 1 point. And then what about the x-intercept? Well, the x-intercept, same thing again. How do you find the x-intercept? On the x-axis, did you remember the pattern? Look at the notes again. What was the pattern every time you wanted it on the x-axis? What did you have to do? And remember, we picked 4, 0. We picked 6, 0. We picked 333, 0. The pattern was y-coordinate must always equal 0. So if that's the case, if we know that there's a coordinate, we know that the y has to be 0, well, how do you work out for x? Well, again, same concept. We substitute y equals 0 into your equation. So what was our equation again? It was y equals 3x minus 6. We know that the y coordinate must be 0. We just don't know what x has to be. Well, this is where you use algebra. You see, you're saying that, well, I know y needs to be 0, and you got 3 times a number, and then you minus 6. Can you see this is what you were doing in the previous term on algebra? This is where you undo the problem so you can solve for x. So here you would say, well, opposite of minus 6 is Sam Dob, if you forgot. Add 6 on both sides. And this is where you get 6 is equal to 3 times x. But I don't want 3 times x. I just want x. How do I get x again? Opposite of times 3. Divide 3 on both sides. And 6 divided by 3 gives you 2. So what does that mean? That means if x has to be 2 in order for y to equal to 0, well, you're saying when x is 2, y will then be 0. That's what you're saying. So that's your coordinates. So let's see if that's true. You're saying that when x, you calculated that x needed to be 2 and y is 0 for you to have an x-intercept. And if I label it, look at that. My straight line crosses the y-axis 0, negative 6, which we calculated. And then it crosses at the x-axis at 2, 0, which we also calculated. And those are the only 2 points you needed to sketch a straight line. It means that even without Desmos just now, you could have just gone to this point and you could have labeled your y-intercept, which you figured out was 0, negative 6. And then you figured out the x-intercept just now, which you wrote 2, 0, and then use a ruler, connect the 2 lines because that's all you need. You only need 2 points to sketch a straight line. And that saves you time, so much more time than doing what you were doing up here. See that? So this is your previous exercise where you were learning how to fill out the table, get the coordinates, and then plot the coordinates, right? It takes too long. We know in theory, you only need 2 points. Well, why don't we just find the x and y-intercept? Because that's the easiest way to do. Now, if you understand what I'm saying today, that is fantastic. That is a huge step. And that's where you start to see how algebra gets applied to solve problems with straight line equations. And straight line equations can be modeled in a lot of situations in real life when it comes to budgeting, to earning taxes, to driving and your fuel consumption. You know, you can work out a lot depending on what it is that you're trying to figure out that has a pattern that's linear. But yeah, that's how you do this exercise here. So have a look at the video again. Just think about what I've been talking about, and then you should be able to then go to these questions in the exercise and have a go. So each one, they want you to find the x-intercept, and they want you to find the y-intercept for every one of these equations. Okay, and you can test on Desmos to see if you're correct. So for example, I can take this one. Okay, so if I were to do this one, y equals x plus 2. So right now, you don't know what it looks like. You can't visualize it, right? But we know we can find the x-intercept and y-intercept. So y-intercept, again, what were the notes again? So y-intercept, for you to cross the y-axis, what do we know about the coordinates? Hopefully you remembered x needed to be 0. So x had to be 0. We just don't know what y is. Well, then we sub x equals 0 into the equation to find y. So here, this is my equation, y equals x plus 2. Well, if x equals 0, well, you get 0 plus 2, y is equal to 2. So what does that mean? That means that when x is 0, the y coordinate will be 2. So there we go, 0, 2. That's my y-axis intercept, okay? Now you only need one more point to sketch this line. So here we go, x-intercept. X-intercept is, well, I don't know what the x coordinate is, but I do know the pattern was that the y is always going to be 0. So according to your equation, again, y is equal to x plus 2, right? You're saying that y needs to be 0. So here, I put it in, I say 0 is equal to x plus 2, and then solve for x. Well, what would x have to be? What would x need to be? Well, in this case, to get x by itself, I need to remove the plus 2. Minus 2 on both sides. And so then you get x is equal to negative 2. Now, what does that mean? That means that you knew, well, for you to have an x-intercept, y had to be 0, and you just did your calculations and you found out that x is -2. So your coordinate for the x-intercept is at -2, 0, which is over here. -2, 0. Use a ruler. Connect the two dots together because that's all you need. You only need 2 points to sketch a straight line. And there you go. Now, let's see if Desmos is correct, or if we're correct with Desmos. Okay, let's go back to Desmos. I'm going to delete all of this. Y equals x plus 2. All right. So this scenario could be something like every week, Mr. Tran's going to give you an extra $2. Okay, so every week, X is the number of weeks, and every week you're going to get an extra $2, right? So let's see, according to this line, what is 0, 2? It means in the first 0 weeks, you started off with $2. Okay, so when X is 0, Y is 2, because that's what we, wait, is that what we calculated? What was it again? Yeah, 0, 2 was your y-intercept. Let's see if that's true. So I label it. Yes, it is. That's your y-intercept there. And then your x-intercept, what did we have? We had over here -2, 0, right? So let's see. If I type in -2, comma, y0, and here we go. Look at that. -2, 0, the line crosses the x-intercept and then the y-intercept, which is over here, exactly the way we calculated. Okay, so Desmos is nice for you to check your answers, but also start to understand it makes this straight line. Now, why was I talking about every week you earning an extra $2 from Mr. Tran? Well, logically, if you wanted to know how many weeks it's going to take you to earn, I don't know, $8, right? So clearly, looking at the graph, $8 at this point here, by the time you get to 8, when y is 8, there's 6, 8. Now remember, the y value has to be 8 because that's how much you earn, right? Then it takes 6 weeks. If you look at that, it takes you 6 weeks for you to earn $8. So if you want $8 over here, you can look at this and say, well, it takes you 6 weeks. If Mr. Tran gave you $2 every single week, how long would it take you to earn $8 overall? Well, it takes you 6 weeks, especially if you started off with $2 from the beginning. So 0 weeks, you started off with $2, and then by the second week, you earn $4. By the 4th week, you earn $6, and then by the 6th week, you earn $8. And that is an example of, like if you were to use linear equations, you can look at this top half here. How many weeks would it take you to earn $500 then? You see, like how many weeks will it take you to earn $500? So that's where you can use some calculations. Most people will do trial and error to figure that out, but you can actually problem solve using algebra. Okay, so I'm going to stop my video there so not to confuse you any further, but hopefully you got an idea of how we're using algebra and linear equations to problem solve some of the things that we do in our daily lives. Okay.